Hi, everybody. Sorry, my Comcast failed, but at least this time it looks like it came back sooner rather than after they told me it would come back. So I really didn't have much more on that last part in lecture. Let's see, I'm trying to remember where we ended on. Oh, the transporters that are moving things, right? So the only thing I didn't mention, which we can do when we come back in case some people aren't here yet, is the nitrogenous waste. But all of that stuff was kind of review from 103A and from what we talked about in the kidney earlier. So it's pretty straightforward stuff. So anyway, when we come back, we'll talk about the negative feedback loop of maintaining your blood osmolarity in lecture. So it is the beginning of lab, and we have about half of the class here. So I'll give people a couple minutes given that chaos, and then we could start talking about it. But I do want to put in announcements here that I did put up a new version of the urinalysis only because I realized one sentence I hadn't finished writing. And it says, you should give me abnormal condition 4, and then I didn't say what. So so use the latest updated today version of the urinalysis handout. Okay, so if you haven't gotten that urinalysis handout, then, or if you downloaded it or printed it out before, then you can just add the extra words that I hadn't added. If you wonder where it is, it's right at the top. It's number 6. It says, name one normal and abnormal condition that could alter the, and then I didn't put what you needed to address after it. Must have gotten interrupted or something. So the latest version does say what you're going to be looking at for that question is odor, specific gravity, or pH. Okay, where you find all these answers is going to be in the lab manual, but it's also going to be discussed in the videos that are embedded in the study guide. So as people are wandering in, I'm going to open the study guide here again and the handout to help you through this. Okay. So I've been working on this study guide. I haven't changed anything on the urinalysis. So this is all the same as what you are doing. Here it is. You've seen before. I'm gradually adding the things to the digestive chapter, so just pay attention. I'll give you a heads up that you'll need to open new versions of that. Okay, so it looks like I don't have how many people are here, but it looks like more than, here it is, 18. So that's pretty common for this first lab section. So let's get started on looking in the study guide at what you're going to be doing. Now, what you'll find is there's a couple things in the study guide under the folder for urinalysis. And one of them is something I put together last spring when we were, throwing things together, a little PowerPoint, which is based on this video that Kevin made. And so that's one reference you can go to, but it's not going to answer everything, because if we were in person in the lab, you would be doing more tests than Kevin did on his own urine. For example, you would be making a slide of your urine and looking at the salt, organized and disorganized, what are called casts in the urine. So you have to pretty thoroughly study this lab manual exercise. Most of the answers are in that, but to really understand what they're talking about, you need to not only watch Kevin's little video, which does part of that, but these 3 videos, which are all like a continuous story of the various aspects of a urinalysis test that might be done, or you might have had done, as part of a clinical assay. So urine reflects what's in blood, and blood often reflects pathologies of the body. So we talked a little bit today about creatinine levels being high if you have liver disease. You know probably that blood glucose would be high if you had diabetes. So those are common things that can affect the constituents of urine. So one thing that I would like you to do is fill out this table in the handout. And I realize that the table has some of Kevin's results when he does it with the test strip. But it also has the last column, conditions and causes. Sometimes conditions have a name, like diabetes has a name. And sometimes it just gives you a cause, like liver disease or something like that, that's a little vaguer. So I'd like you to learn that, and where you find that is in your lab manual. Now, the other thing I'd like you to be able to do, which pushes this a little bit past just remembering, is often conditions change multiple variables in your urine. So, for example, if you are diabetic, yes, you will have high blood glucose, but you may also have ketosis, where you have ketone bodies, and that can show up. Your specific gravity, which we'll talk about a little bit, will be elevated. You may have an acidic pH, because if you have uncontrolled diabetes, it leads to an acidic extracellular fluid. You'll be out of your normal range, and you'll have acidosis, and that will be reflected in the kidney. Especially in the kidney, because as you'll learn, the kidney will be attempting to secrete extra H+ ions to help you get over the acidosis. So similarly, there's bladder infections they talk about, and all the various ways it can affect. So when your urine constituents, you could have nitrites, and you could have pH changes, and you could have specific gravity changes. You could have casts present, all related to one underlying cause of having a bladder infection. So play with this table, don't just memorize it. Think about how these variables are all related. And you can see, because it'll pop up, it'll say, the cause of blood in your urine might be a bladder infection, and pH could be alkaline bladder infection. You'll see the same cause in the table in the lab manual. So you might even want to take this and turn it into, various conditions and all the ways they affect the urine. Because in the past, I have asked that on the lab tests, where I say, here are a bunch of variables that are changed. This is how they're changed. What could be one single cause that would be changing all of these variables? So now why there are 3 videos here is because he does some of the same things that Kevin does, but he goes beyond that. He does look at what kind of things called casts appear in urine. So casts are when something is almost like a precipitant, where you're seeing something in larger numbers that clump together. And the table in the lab manual that goes through the tests don't really discuss casts. The casts are discussed in the body of the text of the lab manual. So I made it as a separate thing on the bottom. instead of putting it in my table either. It talks at the end of this handout about casts of organized, I must have not been very together. It should say of organized sediments, casts or organized sediments. Oh, that's okay. Yeah, so you could have casts which are because you have cells in your urine. Now, those cells don't come through the glomerulus necessarily, but they could. You could have, an infection that's causing your bleeding in your urethra or your kidney itself because of inflammation there. And that doesn't mean they're being filtered out, but it could mean you're actually bleeding. And so one condition they bring up is called glomerulonephritis. If I said it right. Where you have inflammation of your nephrons and your glomeruli that are allowing bleeding to occur in the kidney. And therefore, red blood cells appear in the bladder, and they tend to clump together and form these clumps of cells called casts. Those are organized sediments. Same thing with white blood cells. If you have inflammation, they're going to be crawling out of your blood to address that. They may clump together, and again, they may show up in someone who has a bladder infection. So the other one they bring up are hyaline casts, and this has to do with a low glomerular filtration rate in someone. And they talk about why that occurs in the body of your lab manual. So there's also unorganized casts, which means they're not big clumps, they're crystals. They're still a clumping together because it's salts that are crystallizing. So I don't expect you, there's a little picture in there to recognize anything in that picture in the lab manual of various types of ions or salts that can make these crystalline appearances in urine. Just know that that means what it means if you have excess crystals in general. Okay, so that is the handout, and what I'm trying to do with it is have you thoroughly read the lab manual exercise and thoroughly look at what's going on here, since he does things like specific gravity, which we'll talk about in a second. Here he does, the dipstick test that Kevin does here, and then he does the casts and looking at associations of cells, organized cast or unorganized casts. He covers it here. Kevin does specific gravity in a way that is not shown in these strong medicine videos. But I think it makes you understand what specific gravity is better than if you just know it from, say, the dipstick tests that they do in the strong medicine. So what he does is he uses a calibrated float. It has a certain buoyancy. It got air in it, and it has a little bit of weight at the bottom, and that has been calibrated so that if you put this bobbin, it's like a fishing bobbin almost, into pure distilled water, it would read on the scale bar when you look at this video, it would read 1.000 ad infinitum. That is by definition what distilled water is. I don't know why they didn't pick some other number, but they picked 1. So it's just there's no units on this. This is just relative to water, and water is defined as 1.000 forever. So if you add solutes to distilled water, it becomes a little bit denser. So it's almost like adding people into a room. It becomes a little more crowded in that room. And that means that the buoyancy is greater. So you probably know this because if you swim in fresh water, you're less buoyant than if you swim in salt water, if you go into the ocean. All the salts in the water help buoy you up. Well, it helps buoy up the little bobbin in his specific gravity. And therefore, you're not 1.00 anymore. You're 1.0 something or 1. You add something below the decimal point. So they do give a normal range for urine that you should know of its specific gravity. You should understand what those numbers mean, why they don't have units, because they're comparing it to water's specific gravity. And what sort of conditions could lead to a change in that specific gravity. So whenever you add something, so if you have diabetes and you're adding a lot of glucose to your urine, it's going to have a higher specific gravity than it would without that glucose in it, the normal urine. If you add a lot of cells, you have an infection, you're going to be adding more buoyancy as well. And the other thing that it'll do is the urine may change in its appearance. It may look turbid. Turbid means cloudy, basically. So it does ask you at the beginning of the handout to discuss things that could cause a color change, turbidity change. Sometimes those are not the same, but they are all in the beginning introduction part of your lab manual exercise. So that's where you're going, exercise 41. So that's what you're going to be working on today. Hopefully you finish the slides. I did get a couple, I guess I labeled the bladder slide 400 and it should have been labeled 100. Just looking at it, it's 100, but I mislabeled that picture. So you are still turning in the same thing that this study guide says. Let's see if I can, oops, there it is. You're turning in this today. And this actually, well, maybe it isn't exactly right. It should be a 40x and 100. It's not sorry about that. This should be 40. Let me see if I can annotate it. You guys are just the beta testers on a lot of this stuff. Sorry about this. So this should be a 40x and a 100x. The low power, which will allow you to see all the mucosal layers and label those. And then this one, which is not 400, it is 100x. That's all that's available to you in there. Now, there are a couple 40x's, but they are actually the same picture. So I probably had taken a couple pictures of it and then I uploaded each. Doesn't matter which of those two, they're very, very similar. I think there's only one 100x of the bladder. So again, you're labeling these for the 40x, and then when you go to higher magnification, you can't see all the layers, but I would know what tissue subtypes everybody's made from. And this may not be visible, the serosa adventitia. I think maybe I went through this last time, just a little tiny bit of it was visible in the bladder, or maybe none in the bladder picture. Okay, and then the kidney ones. So if you're struggling with any of these guys and you want to share your screen and show me, because these are challenging, then you're welcome to do that. All of this, so it looks like it's 1, 2, 3, 4, 5, 6, 7, minimum of 7 drawings today. So at least 7 or more. Now, why would you have more? Well, you may feel better. There are several versions of the kidney ones. You may feel better at identifying one of the structures you have to identify here in one picture and a different structure in a different. So like I think I showed you, the collecting duct doesn't show up well in one picture, but shows up better in another. As long as you can recognize them and everything's labeled that's on here, everything should be good to go with your pictures. And those are due at 5 today. Okay, let me go and make sure there's nothing in chat, wherever that is, over here. Is there any question? Use the latest handout, that was me. Are there any questions on on this material? Okay. All right. So when is the urinalysis handout due? It's going to be due next week on Tuesday, and we can walk through it. So you'll be turning that in on Tuesday. We can walk through it, but we're going to have to do it quickly because we're going to be working on PhysioX, and when we're in person, the PhysioX on the urinary system usually takes the whole period. What I suggest you do for the PhysioX is that you do break up, or maybe I will just break you up into breakout rooms so that you can work together on this. That means you'd have to be running this either by sharing screens with each other, which I don't know if you can do in a breakout room, maybe you can, or, simultaneously looking at your screens to work on these handouts. It's really useful in these to talk about it with each other. So if you really have an objection to that, I won't make you do that, but that's what I would plan. And it really does take most of the hour-and-a-half period to do that one. On Thursday of next week, we're doing a second PhysioX on acid base, and it's a lot shorter. It doesn't take the whole period. So if there are questions on the first one, we can probably go over that. And then all of those are, both of those are due together. If I remember right, I'm making that due on the day of the test. So, any questions, you can pop up and just take your microphone off, or you can type them in. I kind of rushed through because I was afraid I'd lose internet again, but so far we're good. Okay. All right, so let me finish up by just seeing if anyone wants to be in a breakout room now. I'm happy to do that. Put that into the chat, and otherwise I will let you start working on the videos and the urinalysis. At any point you have a question, you're welcome to speak up and ask me. Okay, so I've got one request for a breakout room, and I'll set that up. So anyone else, just again, do that whenever you just put it in chat. Let me see if I can, maybe I'll stop sharing and that will help me find things because they keep changing where things are. Okay, we'll go one breakout room, assign manually, create, I'll make it for 45 minutes. Probably have more than that in the lab, right? Maybe I'll make it for 60 if we want to make it full time. Okay, and